Welcome back. We're going to discuss built-in types. And what's important is that there are two different types of built-in types: value types and reference types. We're going to go through the value types first, and then we're going to talk about reference types. So there are a number of built-in value types that will be used in different ways. And so we'll just start with bool. Clearly, bool can be true or false. Now, moving on to byte. Byte is a numeric type. It is unsigned. That's why its minimum value is 0, and its maximum value is only 255. Now, there is a signed byte where you can have a negative 128 through 127. But note that consistently, unsigned versus signed is the same range. It's just that unsigned has a higher upper bound because it doesn't have to accept any negative values. That'll be important as you choose which type to use in different situations. Char is a built-in value type that is built to represent a single character. That character doesn't have to be alpha. It can be numeric, it could be a semicolon, it could be anything. But keep in mind that char really represents a numeric value on the code page, which is why we're going to cast it to int here. And there is a default value for char. Now, I'll just go ahead and visit this for a second. So default is not uncommon for value types. In fact, it is expected because value types by definition cannot be null. Therefore, they all have a default value. Now, moving on to decimal, you can see that's a monster number. One thing to note is that the precision on decimal is retained. So when you do division or multiplication, the precision to the right of the decimal will be retained based on whichever decimal has the largest precision. Just keep that in mind because it can be a gotcha if you're not dealing with numbers that have the same precision. But double and float are inordinately larger numbers with different kind of precision. The precision to the right of these decimals is I guess it moves. It's changeable, right? So if I were to divide two doubles, I might get back a double that has an entirely different precision based off rounding and all that kind of stuff. Same with float. But if you're doing scientific calculations, those are the right value types for it. Now, looking at integer, it's a very large range here from negative to positive, right? So for large numbers, numeric values that have no precision, this is the right type. Now, if you have extremely large numbers, but you have no negative values you have to deal with, then unsigned int is the right way to go. Now, long, or int64, right, is an even larger integer with much broader range. Same for unsigned here, right? Obviously, the only difference is that here you have negative numbers possible, and here you don't. Now, if we look at short, it's one of those that's kind of in between byte and int, right? You're dealing with numbers that are a little bit larger. And so, again, the amount of memory that you're using here is important, especially if you're doing large calculations, you're trying to hold a lot of this stuff in memory. You got to keep in mind how much memory you're using for the numbers you're using. So if you're storing the numbers from 1 to 100, you shouldn't be using ulongs or longs to store those and do the math. Because you're just wasting memory. It's not necessary, right? You could use a byte to do that. So just keep that in mind. Int is really common. A lot of people use integers all the time, but that doesn't mean it's always the right decision. Now let's move on to the fact that types or value types can be nullable when they're wrapped as a nullable value type. So this definition here, nullable int, is an equivalent definition to int question mark. So it's just a shorthand for the same thing. And what it boils down to is the fact that the integer can have either a value or null. And in both cases, that is a valid value. And there are extensions, properties, and methods on this nullable class that will allow you to interrogate it to decide, does it have a value? Maybe you wanted to get the value or the default, right? Things like that. Moving on to reference types. All reference types can be nullable. That's the first thing you need to know. The next thing you need to know is that all reference types, all classes that you build, base themselves from object. So up here, when we built this class program, its base class is defaulted, or by definition, object. Dynamic is an interesting type in the sense that it can be an object, it can be a string, it can be an instance of a class you've created, it can be any of those things, it can even be an integer. It's a wrapper for a value is what it boils down to. And so that's something that you can use down the road if you need it. It is a type that is not used that often. Now, if we were to run this application, we would get some output that you could probably use in the future. Notice all these default values at the end, right? Just giving you an idea of what the defaults actually look like for these value types. And so, again, these are the built-in types. These are the things you're going to build on top of. But having an understanding of these types is important. I look forward to seeing you in the next video. Until then, happy programming.